Welcome to this lesson on backup strategies for cloud data protection, part of our Cloud Resilience series. In today's digital landscape, protecting your data is not optional, it's essential. Throughout this video, you'll learn proven backup methodologies, retention strategies, and security practices that ensure your cloud infrastructure remains resilient against data loss, disasters, and cyber threats. Let's dive into the critical practices that will safeguard your organization's most valuable asset, your data. Before we explore backup strategies, let's understand why cloud backups are absolutely critical. First, data loss risks are everywhere. Hardware can fail without warning, human errors happen daily, and cyber attacks are constantly evolving. Any of these can destroy critical business data in seconds. Second, backups are essential for business continuity. They ensure rapid recovery from disasters and minimize operational downtime that could cost millions. Third, compliance requirements mandate data retention and protection standards across industries. Regulations like GDPR, HIPAA, and SOC 2 require organizations to maintain proper backup systems. Finally, ransomware protection has become paramount. Isolated, immutable backups provide recovery options without paying ransoms, breaking the cycle of cybercriminal extortion. Without proper backups, your organization is one incident away from catastrophic loss. The foundation of any solid backup strategy is the 3-2-1 backup rule. This time-tested approach has protected data for decades. Here's how it works. First, maintain 3 copies of your data. This includes your original production data plus at least 2 backup copies. This redundancy ensures that if one copy is corrupted or compromised, you have alternatives. Second, store your data on 2 different media types. This could be local storage and cloud, disk and tape, or any combination of distinct storage technologies. This diversity protects against the simultaneous failure of a single media type. Third, keep at least 1 copy offsite. This means geographic and network separation. Whether it's a public cloud, remote data center, or air-gapped vault, the goal is isolation from any single point of failure. By embracing redundancy, diversity, and isolation, the 3-2-1 rule significantly reduces the likelihood of catastrophic data loss. Understanding different backup types helps you balance speed, storage efficiency, and recovery complexity. There are 3 primary backup types you need to know. First, full backups create a complete copy of all your data. They're the slowest to create and consume the most storage space, but they offer the simplest and fastest recovery process since everything is in one place. Second, incremental backups only capture data that has changed since the last backup of any type. This makes them the fastest to create and most storage-efficient option. However, recovery is more complex because you need the last full backup plus every incremental backup since then. Third, differential backups capture all changes since the last full backup. They offer a balanced approach, sitting between full and incremental in terms of backup speed, storage requirements, and recovery complexity. Most organizations use a combination. Regular full backups with incremental or differential backups in between to optimize both protection and resources. How often should you back up your data? The answer depends on how much data loss your organization can tolerate. For critical data, such as transaction databases, financial systems, or customer records, you need continuous or hourly backups. These mission-critical systems cannot afford significant data loss. For standard data like employee files, project documents, or less critical applications, daily backups during off-peak hours are typically sufficient for regular operations. The key concept here is Recovery Point Objective, or RPO. Your RPO defines the maximum amount of data loss that's acceptable to your business, measured in time. If your RPO is 1 hour, you must back up at least every hour. If it's 1 day, daily backups suffice. Understanding your RPO requirements for different data types helps you design an efficient backup schedule that protects what matters most without wasting resources on excessive backups of less critical information. Once you're backing up data, you need to decide how long to keep those backups. This is where retention policies come in. A popular approach is the GFS strategy, which stands for grandfather, father, son. In this hierarchical model, you keep daily backups called SUNs for 7 days. These provide quick access to recent versions. Weekly backups, called fathers, are retained for 4 weeks, giving you monthly recovery points. Monthly backups, called grandfathers, are kept for 12 months to 3 to 7 years, depending on your needs. This creates a pyramid of protection, with more frequent recent backups tapering to longer-term archival copies. When determining retention policies, consider 3 key factors. Legal compliance requirements may mandate specific retention periods for certain data types. Storage cost optimization balances protection with budget constraints, since longer retention means more storage expense. And business recovery needs determine how far back you might need to restore data for operational or analytical purposes. The right retention policy depends on your unique mix of these factors. Backups are only valuable if they're secure and available when needed. 4 security measures are essential. First, encryption. You must encrypt data both in transit, as it moves to backup storage, and at rest while it's stored. Industry standard AES 256 encryption provides strong protection. Equally important is secure encryption key management, ensuring keys are protected separately from the encrypted data. Second, immutability. Implement write once read many, or WORM, storage that prevents modifications after creation. This protects against ransomware that seeks to encrypt or delete your backups. Air-gapped backup copies, physically or logically isolated from your network, provide additional protection. Third, access control. Enable multi-factor authentication for all backup system access. Implement role-based access policies, ensuring users only access what they need. Conduct regular access audits to remove unnecessary permissions. Fourth, monitoring. Track backup job success rates to catch failures immediately. Set up alerts for failures or anomalies that could indicate problems or attacks. Maintain detailed audit logs showing who accessed what and when. Together, these security layers create defense in depth for your backup infrastructure. Here's a critical truth. Untested backups are not backups. They're assumptions. Many organizations discover during a real disaster that their backups are corrupted, incomplete, or unrestorable. Don't let this happen to you. Implement 3 essential testing practices. First, perform regular restores. Test full recovery at least quarterly, actually restoring data to verify the entire process works end to end. Don't just check if the backup job completed, verify you can get your data back. Second, conduct integrity checks. Verify backup completeness and data validity regularly. Automated tools can check for corruption, missing files, or other issues without full restoration. Third, run disaster recovery drills. Simulate realistic disaster scenarios annually, testing not just the technology, but your team's ability to execute recovery procedures under pressure. These drills identify gaps in documentation, reveal missing skills, and build confidence. Remember, the only way to know your backup strategy works is to test it repeatedly. Make testing a routine part of your backup program, not something you only think about after disaster strikes. Let's review the essential concepts for effective cloud backup strategies. First, always follow the 3-2-1 rule. Maintain 3 copies of your data, store them on 2 different media types, and keep 1 copy offsite. This fundamental principle protects against the widest range of failure scenarios. Second, balance backup frequency with your recovery point objective requirements. Critical systems need frequent backups, while less important data can use longer intervals. Match your backup schedule to your actual tolerance for data loss. Third, encrypt your backups, secure access with strong authentication, and make backups immutable to prevent ransomware modifications. Security isn't optional, it's fundamental to backup effectiveness. Fourth, test restoration regularly and never trust untested backups. Only through regular testing can you confirm your backups will actually save you when disaster strikes. By implementing these strategies, you create a comprehensive backup system that protects your cloud infrastructure from data loss, ensures business continuity, and provides peace of mind. Effective backup strategies are the foundation of cloud resilience.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.